Hello, today we are going to be starting a new chapter. That chapter is all about functions. Hopefully you've seen functions before, but I want to do a little comparison to some things we've seen and, a function. So on the left-hand side is an equation. It's an equation because it has an equal sign, and that one happens to have two missing letters, a y and an x. On the right-hand side, it's essentially the same exact problem. It's just written in function notation. I want you to see the difference. The y equals has been replaced with function notation. F of x is how you would read that out loud. All right? So we're going to try a problem so you can see both things are the same. So on the left it says substitute x equals 4 and solve. So that means I'm going to take that problem, I'm going to rewrite it, and everywhere I see an x, I'm going to take the x out of the problem, and in its place I'm going to put in a 4. Then I'm going to use order of operations to find the answer. All right, I would do 2 times 4 first because multiply comes before add, and then I would add the 8 plus 3. Now if I was using function notation, it's going to look very similar but a little tiny different piece. I'm going to write it as f of x, except for now I know what x is. X has been replaced with the 4, so I write the 4 every single place I see an x, and that would be in 2 spots. 1 in the beginning in function notation, the f of 4, and then the second part on the right-hand side where the actual problem is. Now when I go to do the work, I'll still write f of 4, function with the number 4 being used, and then that's 8 plus 3, just like the other one, and the answer equals 11. But I want you to see how it's written. In this manner, when you use function notation, not only do you see the answer, which is 11, you also see the number that I used to get the 11. You can see the 4, whereas in the other one, the equation, you don't know what number I started with. You just know the answer only. So that's one of the reasons that functions are useful. They show you the answer, and they show you the actual number that you used when getting that answer. All right, so here's the steps for doing our work today. We're going to be doing what's called evaluating functions. Evaluate essentially means find the answer. So on the right we have an example. F of x, again that's how you read this in function notation, f of x equals negative 3x plus 1. Step 1, replace all x values with the given value. So again, that means everywhere. That means f of x equals negative 3x plus 1. Everywhere I see an x, I take it out and replace it, in this case, with a negative 2. And again, there were 2 x's there. One here in the function notation, one over here in the actual part of the problem. All right? Step 2, use order of operations to find the solution. So the function, when I use negative 2, equals, well, I do multiply before I add. Negative 3 times negative 2 is 6, and then plus 1. All right? The last piece is to make sure that when you have your final answer, it's written in function notation, which means I don't want just the answer. If you just put 7, that's not good enough. I also want to know what number did you put into the problem that got you the answer of 7. So that f of negative 2 part is important and is a requirement for your answer if you were showing your work on a problem like this. All right, let's try one more. A little bit harder one. All right. This one would be one where you would definitely probably want a calculator. But let's talk about how it's done. All right, so I have my actual problem, my function. F of x equals negative 3x squared plus 2x minus 4. And I want to find f of 2. So what that means is I'm going to rewrite the problem, and everywhere there's an x, I'm taking the x out, putting parentheses where the x used to be. And then in those parentheses, putting in this number, 2. All right, now again, if I was you, I would use my calculator to do this answer, and I wouldn't really have to do any actual math. Just type it in on a calculator exactly the way it looks. You have access to the Desmos calculator. The scientific calculator on that will do this whole problem all at once, give you the right answer. You don't have to do it all. All right, so let's do that. All right, so again, if you were doing it, calculator would do the parentheses first. That means this part would get done first. So I would have 3, and then 2 to the second power makes 4. So that's what I would have to do first if I was following order of operations. Now the parentheses are still there, but there's no work inside of those parentheses, just a number. So then I would go to exponents. I don't have any. Then I would go to multiply and divide, and I've got two multiplies. I would do both of those right now. 3 times 4 is 12. 2 times 2 is 4. Right? And then in the end, I want to write my answer in function notation. F of 2 equals, and 12 plus 4 minus 4 equals 12. There's the first answer. All right, you would do the same thing on the second one, except this time you would plug in a negative 2 in every single spot where there used to be an x. And again, if you're bad with numbers, use a calculator for this part. That's what the calculator is for. Calculator is to make this part easier and faster. So go ahead and use it. That's the whole point. All right, but if I wasn't, I would still, again, start with the parentheses. There's nothing inside, and then there's this exponent. I'd do that first. Negative 2 to the second power means negative 2 times negative 2, which would make positive 4. And then just like the last one, I would go ahead and do the multiplies next. I'd get negative 12 minus 4 and minus 4. And then the final answer. Make sure you write it in function notation. Negative 12 minus 4 makes negative 20. All right, again, I don't need to see your work. I am expecting your work to be done partially on a calculator on an assignment like this. So answers only is all we need today. So again, if you need any help, you know how to get a hold of me on the Zoom. All right, good luck.